Welcome to Modern Retrogramming with Plasma. This episode introduces the Double Color High-Res Graphics Toolkit. This toolkit uses the Double High-Res Graphics mode as 16 color with 140 by 192 pixel resolution. I attempt to provide a library and tools to help in development of this challenging environment. First is support for a generic pixmap format with transparency that can be used directly as a source image or converted into an internal format that takes up more memory but greatly increases performance. Here we see a sprite image compiled into a sequence of images and masks for faster drawing on the left and converted into tiles on the right. Colored line drawing comes courtesy of the generic draw line module and providing a double color plot pixel routine to it. The double color toolkit only uses a single display buffer because double buffering in this mode takes an exorbitant amount of memory and is even more mind-bending to use. To make up for only having a single display buffer, memory buffers serve as rendering surfaces that can quickly be copied to the screen. Text output is provided by the use of the other generic graphics format, the bitmap. Each bit is rendered as a colored pixel or transparent if 0. For this test output screen, a section of the screen at the bottom, as outlined by the white rectangle, is saved as a back buffer. The test sprite is then bulleted into a temporary buffer, first using the compiled sequence of images, or using the generic pixmap sprite as demonstrated later. The black window allows sprites to be overdrawn, erasing the previous image due to its black border. This is much faster, and the pre-compiled sprites really show off their speed potential. You can see the difference between the background masked compiled sprite isn't that much different than the background and pixmap. Copying the background and masking the compiled sprite overwhelms the benefit of the compiled sprite, making it almost a wash with the more memory efficient pixmap sprite. When comparing the overwrite method, the compiled sprite is a clear winner. Another option is to XOR the sprite as a method to preserve the background and erase the sprite, but this comes at a visual and performance price. The last sprite demo uses a spinning enterprise, first using XOR to draw and erase the sprite, then using a draw and block erase sequence. Both methods cause flicker when animating the sprite. The last method again uses the compiled sprite for a visual and performance win. The final demo is a dither test of a 25%, 50%, and 75% blend of all the colors. The 25% and 75% blends are just mirrors of each other. This certainly looks best on a composite color monitor. Now, to help with the task of creating sprite assets for your project, there's a rudimentary sprite editor. Low-res graphics is used to create and edit zoomed-in versions of a sprite up to 40 by 48 pixels. The cursor shows the current color and location of the pixel to edit. The sprite can be viewed on the double color high-res screen to see how it actually looks. Thanks again for watching. Hope you liked it.